This is section 3.8, part 2. And in part 1, we talked about parallel lines and how to find parallel slopes and all those types of things. And now in part 2, we're going to talk about perpendicular lines and perpendicular slopes. So when two lines are perpendicular, the product of their slopes is -1. So numbers with the product of -1 are opposite reciprocals. Okay, so let's talk about opposite reciprocal first. And you can add this in. For example, if I ask you, if I were to ask you, what's the question? What is the reciprocal of 1/2? Well, the reciprocal of 1/2, essentially the reciprocal means to take and flip the fraction. Okay, so really the reciprocal is 2/1. Same thing if I go 3/4, the reciprocal is 4/3. The top becomes the bottom becomes the top. Opposite reciprocals simply mean it's the opposite sign. So if it's positive, it becomes negative. Or if it was negative, it becomes positive. That's going to be very important. Okay? So it says here, if two non-vertical lines are perpendicular, then the product of their slopes is -1. If their slopes, the product of the slopes is -1, then the lines are perpendicular. Any horizontal line and vertical line are perpendicular to each other. A line with no slope and a line with undefined slope and zero slope are perpendicular to each other. Okay? So, how do we go about drawing, or in this case, finding the equations of lines that are perpendicular? Well, it's the same steps as parallel, except step number 1. Step number 1, it says identify the slope of the line that they give you. That part's the same, but then when you identify the slope, your slope is the opposite reciprocal of the slope given. Okay, that's the only thing that's different in identifying parallel perpendicular. That's the only thing that's different between those steps. So, let's take a look at some examples. We're not going to worry about this example here on the bottom of this page. Okay, so let's take a look at this first example here. It says, what is an equation of a line perpendicular to y equals 1/5 x plus 2 that contains the point 15, -4? Again, these steps are going to be the same as they were before, except one difference. Again, so as I look at this equation right here, identify the slope of that equation. Slope. Okay, so when you get finished with this first example, you end up with y equals -5x plus 71, which again, it is perpendicular to this line right here because the slopes are opposite reciprocals. Okay, let's take a look at the second example here. What I want you to do on the second example is hit pause, figure out, see if you can come up with the correct answer, and see if you get it correct. Okay, now that you've hit pause, let's take a look at how to do this one. First thing we want to do, identify the slope. So m is going to equal -4 in that equation. That means that my slope is going to be the opposite reciprocal of that, which in this case, the opposite means it's going to be positive. The reciprocal of 4 is 1/4. And I've got the ordered pair 2, -3. Okay, so we're going to plug it into this again. So we got y minus -3 becomes plus 3 equals the slope of 1/4 times the quantity x and then minus 2. Okay, so now I'm going to distribute the 1/4. When I distribute the 1/4, y plus 3 equals 1/4 x. And then 1/4 of 2 happens to be 2/4, which is -0.5. Or 1/2. Okay, so now I want to subtract 3. And when I subtract 3, y equals 1/4 x minus 3.5. This line right here is perpendicular to that one because the slopes are opposite reciprocals. Okay, so as we look at these other three examples down here, it says line AB contains the points A and B. CD contains the lines points C and D. Are A, B, and C, D parallel, perpendicular, or neither? And explain. So how are we going to identify that? Well, the only way we can identify whether they're parallel, perpendicular, or neither is to find the slopes. So on number 1, I need to find the slope of line AB. So I'm taking these two ordered pairs here, 1 and 2, and I need to find the slope. So I'm going to take 11 minus 3 over negative 4 minus negative 8. That's going to give me 11 minus 3 is 8. This becomes positive. That's 4. 8 divided by 4 is 2. So the slope of line AB is 2. Slope of line CD. I'm going to take 2 minus 3 over 1 minus negative 1, which 2 minus 3 is negative 1. These two both become positive, and that's 2. So now as you look at these two numbers, we have to decide, is it parallel, perpendicular, or neither? So if it's parallel, that means that those two numbers are going to be exactly the same. So we know it's not parallel. If it's perpendicular, they're going to be opposite reciprocals. Well, we've got 2, and then we've got negative 1/2. Those are opposite reciprocals, so these two lines are perpendicular. Okay, so let's take a look at number 2. Again, got to find the slope of AB. That's going to be negative 1 minus 5 over 2 minus 3. That's negative 6 over negative 1, which is positive 6. Find the slope of CD now. CD, 16 minus negative 2 over 10 minus 7. This becomes a plus. That's going to be, in this case, 18. And 10 minus 7 is 3, which is also going to be 6. So again, as I look at these two numbers, they're exactly the same. That means that these two lines are parallel. And then the last one, AB. Got to find the slope of AB. 1 minus 1 over 4 minus 3, which is going to be 0 over 1. And then for CD, it's going to be 6 minus 9 over 2 minus 5, which this is negative 3 over negative 3, which this is positive 1. Now, as you look at this, these are not the same, so we know they're not parallel. They're not opposite reciprocals, so we know they're not perpendicular, which means, in this case, this is neither. They're not perpendicular, and they're not parallel. Okay, so this concludes Section 3.8, Part 2, talking about perpendicular lines and slopes. Don't forget to complete your WSQ.